It seems like for most of the people I work with, for our entire careers, we've been focused on things that are in the very, very near term. And we also think about things that are in the second, third horizon, things that might not happen for 5, 10, 15, 20 years. And it's really fun to be able to think down the line like that. And when we think about things in the future like that, we think about potentially autonomous capability, either for freighters or for passenger airplanes. We think about more efficient ways of extracting power from engines to power the airplane, for example, electric propulsion or electric hybrid propulsion, things that are both more efficient and also more carbon neutral.
Does the autonomous technology exist at the moment?
There are aspects of the autonomous technology that exist today. And if you think about autonomous capability, it's a series of building blocks. And depending on what the requirements of the system are, the technologies may or may not exist. For example, the technology exists for unmanned airplanes that can provide reconnaissance. They can provide disaster relief. They can look at how widely a flood has spread. They can look at where a fire is. They can map the ground. That doesn't mean that they can carry people safely 1,000 times a day, which is the bar that we have to meet if we're going to use autonomy for commercial transportation. Now, I'll also say that our airplanes, all of our airplanes, have some level of autonomous capability built into them today. For example, all of our airplanes auto-land. And the act of auto-land it's an autonomous operation that's performed by the airplane, but with full-time human oversight. So that's an example of autonomy that we make use of every day.
The future, is it going to be with passengers or freight or search and rescue?
Well, if you think about that's a great question. Search and rescue is happening today. So there is autonomous operation for search and rescue today. Really more search and mapping. I think if you look down the line in the distant future, then for sure you're talking about passengers and freight. From a societal perspective, I would imagine that freight will be easier to start with. And so as we think about autonomous capability, our thoughts first go to small freighters as a way of entering into that space, demonstrating the safety and reliability and learning all the things that we need to learn in a way that doesn't endanger human beings, and then moving slowly into the passenger space. Now, when I say slowly, we don't know if that's 15 years or 50 years. We know it's down the line. But to understand that, we have to start doing the R&D, we have to do the demonstration programs, and that's how we learn.
Can I ask you about the regulatory aspects, things like European Aviation Safety Agency? Are you working with them?
We're working with the FAA, and we're just starting to engage EASA as well. And I would say that our history at Boeing, whenever we develop new capability, we work closely with the regulators on what the right requirements are and what the ways are that we would validate those requirements for certification. So we always have done that, and I'm sure in this case we will as well.
What's it going to mean to the average air passenger, and when will the air passenger notice any difference, if ever?
Well, the goal would be that they never notice a difference. And so to the people flying in the airplane, it should be transparent.
Mike, can I ask you about integration of all the other aspects of flying? For instance, taxiing on the ground. Will autonomous flight be able to cope with this?
Well, that's a really good question. And in fact, it's interesting to know that some of the airplanes that fly autonomously today require that they get towed out to the end of the runway. They do the engine start and they go from there because they don't have the technology to do the taxi operation autonomously, safely. So that's an area of focus for us right now in our research and development activity. We're looking at auto taxi, which means that you have to have surface operation collision avoidance capability. So as the airplane's taxiing, it's got to know where all the other obstacles are. It's got to know which obstacles are human, which are static, which are airplanes, and which pose threats to the airplane that's taxiing. And that in and of itself is a really tough problem to solve. And we're working on that problem right now because it's one of the building blocks to eventual autonomous capability. Auto takeoff is another example. Our airplanes can land automatically, but none of them take off automatically. And so we have to develop the technology that allows an airplane to do an automatic takeoff. One of the most important decisions a pilot can make in any flight that they perform is to understand whether or not the engines are operating appropriately for takeoff and whether the runway is clear enough to perform the takeoff. And the rejected takeoff decision is a tough decision that a pilot has to make about whether to stop the takeoff at high speed or continue the takeoff. And so this is an example of a capability that would need to be provided by an artificial intelligence algorithm of some sort that understands the operation of the airplane, that scans the visual field ahead of the airplane, and can make the decision about whether to continue the takeoff or to reject the takeoff. Again, another example of a building block. I also believe that we will continue the path on the reduction of the carbon impact of the industry. There's several ways that can happen, either through the use of biofuels or the application of more efficient technologies such as the use of electric power or hybrid electric power. Ultimately, those have a carbon impact, certainly, but we will continually be looking for the ways that where we can evolve to the least amount of carbon impact.